Hello guys, my name is Pranil Deshmukh and I'm going to continue the topic that we started in the last video, that is Hadoop architecture. In the previous video, we studied about the DFS and HDFS architecture. Now the agenda of this video is to focus on Hadoop cluster and data blocks in HDFS. So now let's take a quick sneak peek of Hadoop cluster architecture. A Hadoop cluster is a special type of computational cluster designed specifically for storing and analyzing huge amounts of unstructured data in a distributed computing environment. So this is how an overview of Hadoop cluster will look like. So Hadoop cluster is nothing but a master-slave topology in which there is a master machine as shown on the top and slave nodes. This master machine will have your name node defined it in the previous video, and the resource manager running. Now this master machine is connected to all the slave machines using the core switches. It is because these data nodes are actually stored in various racks. So in the diagram, as you can see, computer 1, 2, 3 till n are nothing but slave machines and the data nodes. Now the question is, what is a rack? Defining a rack is nothing but a group of machines that are present physically at one particular location and are connected to each other. We can have n number of racks and n number of machines, or else I can say slave machines within the racks. All the slave machines are connected to the master machines using the core switch. So they are not directly connected, they are indirectly connected via core switch. Hence, every slave machine is actually distributed over the cluster. However, they are connected to each other. So this is how a Hadoop cluster will look like. Now I will move on to the next part, that is, let's talk about how data is stored in HDFS. We are slowly moving into details of how HDFS works altogether. We will be exploring the architecture of HDFS by knowing how the data is stored. So guys, don't lose me, be connected. When I say storing a file in HDFS, it means that the data gets stored as blocks in HDFS. The entire file is not stored in HDFS. It is because, as you know, Hadoop is a distributed file system. So say if I have a file size of maybe 1 petabyte. So 1 petabyte kind of storage is not present in one single machine. Since the Hadoop cluster is made using the commodity hardware we have defined in the earlier video. So the hardware in one single machine would be somewhere around 1 TB or 2 TB to the max, right? Your hard disk is our single machine. So the entire file needs to be broken down into chunks of data, which are called nothing but the HDFS blocks. So the data that gets stored in the Hadoop cluster is broken down into blocks, smaller blocks. Now these blocks are 128 MB in Apache 2 cluster. It's a default size of one block. However, in Apache 1 it is used to be 64 MB. Later on they upgraded the size. To understand this mechanism, let's try and take an example. Altogether, how does blocks gets created? A file size of 248 MB right here, as you can see in the diagram. Now if I break this file, or if I move this file into the Hadoop cluster, that is Apache 2.x, this file will get broken into one block, that is a block A of 128 MB and another block that is of 120 MB. As you can see, the first block was 128 MB produced straightforward, that is the very first slab cuts down there, and that is why the other block was of 120 MB and not the 120 MB of size. That means that it is not going to waste any space. If the file size is smaller than the effort block size. I hope you guys are clear with what is blocks in HDFS and how they are created. So now let's move on and try to find an answer to another question, that if to have just one copy of each block. What do you think, guys? What do you think? Is it fine? Obviously not. Who doesn't want a backup, right? So it is because if you have a file stored in one particular machine, or I can say if you have only one single copy of your data, there is a chance that if the system gets failed, because it is nothing but a commodity hardware, as you all know, I'm not going to get that file again, right? So I have to lose it. So let's see how does Hadoop take care of it. Now in the earlier slide I told you that because of every block that gets stored in the Hadoop distributed file system, and this is how Hadoop is a fault tolerant system. That means even though your system fails, you will have multiple other copies present in the other data nodes, or I can say in the server connected to the master machine, so that you can always have those copies of your data and you can pick from there. Let's try and understand this diagram. As you can see on the left, from blocks of a file, that is block 1, 2, 3, 4 and 5. Let's talk about block 1. First, you will find the copies of block 1 in node 1, node 2 and node 4, as you can see. Similarly, block 2 has also got 3 copies, that is 1 in node 3, node 4 and node 2. Also, block 3 is present in node 1, node 3 and node 4. Similarly, block 4 is present in node 1, node 2 and node 3. And the last block, that is block 5, again it has got 3 copies, that is present in node 1, node 2 and node 4. So I'm going to ask you one question here. Apart from replicas getting created, what is one common thing that you can see in this particular diagram? We can see that they are creating replication of 3. Every block, as you can see, has been replicated thrice. That means Hadoop follows a default replication factor of 3. That means any file that you can copy into the Hadoop distributed file system gets replicated thrice. Again, there will be 3 copies of every file. So in other words, I can say if I save 1 GB of file into Hadoop distributed file system, it is actually storing 3 GB of file in HDFS. As we have read earlier, it creates 3 copies. Solving one question of storing the file data and having a backup, we created a new question. That is, we are actually storing 1 GB of data, however density replicas are being created. So by that logic, you are almost wasting 2 GB of space. So doesn't that give you an alarming bell in your mind that why are we doing that? Why are we giving up the space of 2 GB? It's a complete waste. So I'm gonna ask you this. Have you thought about the cost of Hadoop? I was coming from the perspective of cost, that the storage is very cheap. Hadoop basically doesn't need anything to set up. We are using a commodity hardware here, don't forget. So we can add as many data nodes as we want, or as many hard disks to our data nodes as we want, and hence storing the data will not be a problem. We can store as much data as we want, and hence replicating is not at all a problem for us. It is just that we should not over replicate the data, as it's like there is no need of creating 5 replicas of the same data. 3 would be enough, and already Hadoop is doing that for us. So in this way, the data blocks in Hadoop are used for storing the data, and data replication works. And here we come to the end of the session now. If you have any queries or doubts, please comment in the comment box. I will try to answer it. Also, I have left some questions for you, so try to answer it, and let me know if you like this session. Before that, answer this question. What is a rack? How many replicas of data are created in Hadoop? And the last question is, how are slave machines connected to the master machines? Now I hope you can answer this. So I'm gonna end this session now. Thank you so much.